Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 406, and I solved our 4 problems in around 17 minutes. So I have a pretty decent rank, but it seems like it was a lot easier as a lot of 1300 and 1400 are on top rank page. So let's just dive into the problems. So first problem is lexicographically smallest string after a swap. So we are given a string of digits and we have to perform at most one operation, which is swapping adjacent digits in S if they have same parity. So for example, 45320. Now uh, there are multiple possible swaps which we can perform. One is 5 3, another is 2 0, because they have same parity, but we can only perform one operation. And if we perform this operation, the overall number would be 43520, and if we perform this operation, number would be 45302. Now if you check the lexicographically smaller string, it would be this. So it is always optimal to perform first whatever first pair of adjacent digits, such that the second digit in that pair, if it is less than the first digit, we can swap it. And it is all optimal to swap the first ever occurrence of such pair, because if we don't swap it and swap something which is after that first occurrence, the it would not result in lexicographically smaller string, because in lexicographically smaller string, what matters is first non-different first different character. So original string was 45320, and after swapping it becomes 43520. So in lexicographically smaller string, what matters is this first character, which is different. So the optimal operation is first ever pair in which second digit is less than first digit, and then just swap it. So this is a implementation problem. First I'm iterating from 1 to n, finding these two digits d and d2. If both of them have same parity and the second digit is greater than first digit, I will swap both of them and basically break from this loop, as I have performed one operation, and finally return the string. So this was first question. Now second is a bad question, I would say. Linked list problems are if they are asked in a contest, it is bad, I would say, because linked list uh, I basically hate this type of problems. So let's just discuss. First, we are given an integer array nums and a head of a linked list, and we have to modify the list such that we have to remove all the nodes from linked list such which have equal which has a value which exists in our vector nums. So this is the original linked list 1 2 3 4 5, and this is the nums 1 2 3. Now we have to return a linked list such that it only contains 4 5. Now we removed the nodes 1 2 3 because 1 2 3 was uh, were present in nums. Similarly, here nums was 1 and the linked list was 1 2 1 2 1 2, and removing all the occurrences of 1, we got the linked list as 2 2 2. Similarly, you can understand this. Now this is a simple implementation problem. Just create a new head, new linked list, instead of deleting from this, it would be easier and less implementation heavy problem, heavy problem. So first of all, what I'm doing is I'm making a set of nums, because the search would be login if I for every node. If I would have just kept it nums, I would have required another of and for loop in for searching in this head. Or I could have just sorted this nums and used lower bound or binary search, but I found this easier. Then I declared a ch, which is just if I have this basically represents a condition that for if ch is equal to 0, that means I have first encountered a value which is not present. So for this while loop, for iterating over the linked list, and if I cannot find the value in my set, if ch equal to 0, I have declared a current new list node. First of all, I'm assigning it value and making ch equal to 1. Else means I haven't encountered any. I have already encountered one value which is not present in set. Then what I will do is I will create a new node, assign its value, then the current which was previous head of the linked list, I will just make current equal to next with this new node, and make current iterator move to next pointer. So this was the second question. I would say I found this little bit difficult to implement. I have to remember all the syntax of linked list and stuff. So uh, it I took some time for implementing this. Normal B would have been solved faster, but this took some time. Now third and fourth problem are, so in both of these questions I just the only difference is between the constraints. So here constraints are 20, but here constraints are 10 raised to power 5. So I read both the problems and I basically couldn't solve the third problem, or couldn't find any approach, any brute force approach also for third. So I directly jumped into the efficient solution. Now after thinking for some time, the brute force approach for this question would be DP with bit mask. So let's just understand the question first. So we are given a grid of m into n size, and we have to cut it into 1 into 1 pieces, and each line in that grid, except the last borders, have some cost of cutting that line. So if we are cutting an horizontal line, the cost would be horizontal cut of I. So we are given these two vectors also, and we have to return minimum total cost to cut entire grid into 1 into 1 pieces. So let's say there is a 3 into 3 grid. Let's say this has A cost value, this has B, this has C, and this has D. Now the first observation is that we have to make at least one cut of each line. That means we have to make at least one cut with this A cost, at least one cut with B cost, at least one cut with C cost, and at least one cut with D cost, to have all of them to get one into to divide the whole grid into 1 pieces, because if we don't perform this and we perform this any number of times, this part will not never get divided, will never be divided. So for getting all for dividing the whole array, whole grid into 1 pieces, we 1 pieces, we uh, always need to perform at least one cut for each line, each horizontal line and each vertical line. So it is always optimal to it is required to perform at least one operation. So we have to add all ABCD cost at least once. Now second observation is, if we cut A first, like if we cut this A here, we need to perform 2 times C and 2 times D. Why is that? So after, let's say after we cut A, the grid will look like this. And the cost here was B, cost here was C, and cost here was D. Now we don't require A anymore, so I'm not writing it. But C, we cannot cut through this two grids at same time. We have to cut them separately. That's the condition of this question. So we need to cut C twice. First for this grid, second for this grid. Similarly, we have to cut D for one for this grid, two for this grid. So the all the previous operations which we performed affects the cost for next operations. Now if we perform C now, let's say after A, if we perform C, now this will lead to performing two B operations. D will not be affected, but we have to perform two B's now. Why is that? After performing C, the grid will look like this, then there will be this 2, and B will look like this. Second grid will look like this. Now this is B. So again, for making we need to make two cuts using this cost B, one for this grid and two for this grid. So second observation was that the whatever cut we make at this stage will affect all its next cut, all the cuts which are made after this. Now third observation would be a type of guesswork or optimal way of cutting, but it's easy to understand by looking at some example. So let's say I have three cuts, 8, 7, 4. Now this would be represented by 2 into 3 grid. Let's just make a 2 into 3 grid. Let's say this is 4, this is 7, and this is 8. Now it is always optimal to cut the highest cost first. Means in here we have three options: either cut 8, either cut 4, or either cut 7. Now after cutting 8, what would be the effect of cutting 8? It would be something like plus 4 and plus 7. After this we have to do it, because after cutting 8, 2 into 4 and 2 into 7 we have to do after this, because after cutting 8 it would look like this two grids, And to cut for 4, we have to perform two operations, one on first grid and second on second grid. So two operations for 4 and similar for 7. If we cut 4, we need to perform two operations of 8 but only one operation of 7. And if we perform 7 first, then we need to perform two operations of 8 and one operation of 4. Now after this, if we cut 8 again after 4, if we cut 1 8, then we need to perform 8 and 7, and after which this process will continue until all the cuts are made. So this is the end condition. Now if you try to understand this, that whatever operation we perform, its contribution should be minimum to next cuts. Now if we perform 8, the number of multiplier will remain same after this, but the values which are remaining after this would be lesser than this original cut. Similarly, if we perform 4, the values which are contributing after this are bigger than 4. So eventually this will lead into higher cost than this. So it's kind of a guesswork which I did. I didn't proved it completely. I just did a guesswork, and what that guesswork was, always cut the first cut which start with the cut which has maximal cost, because if we don't do that right now, it might add higher contribution if the more we do it, the more we wait. So performing 8 on first, performing 8 on third cut, and performing 8 on 7th cut, let's say there are a lot of cuts, so the cost which this value will contribute will be highest when it is performed at 7th cut. This would be less than 7 but greater than the value which we get by making one at first cut, and this would be minimum. And this contribution difference would also be higher for values which are maximum in the set. So for 8, if we compare it with 7, the difference between cost for 8 would be higher than difference between cost for 7. So it will be, the difference would be directly proportional to the value which we are working with, or the cost which we are working with. So using these 3 observations, what we need to do is start cutting the grid with highest cost, and also maintain what it affects. So cutting A would affect two requirements, two costs of all the horizontal cuts. So cutting A means there are two parts of grids now, so 2 into C and 2 into D would be required. So you also need to maintain this difference in a linear manner or logarithmic manner, because quadratic would not work. So how I'm doing it is, first of all, I have declared to a pair of vector, and I'm pushing all the costs hi with 0 and 1. So this second int in pair is for identifying it is an horizontal or vertical. Then I'm sorting the A by first value in the pair. Then I have declared three variables. One is my answer, so answer is my final cost. CNT is a number of vertical cuts which I have made before this operation, and CNT2 is number of cuts, a number of horizontal cuts before this operation. So now I starting iteration from the last element of A, so highest cost, and if the current cost is and cost of horizontal of an horizontal cut, then what I will do is I will add CNT plus 1. So number of vertical cuts before this plus 1 into A of I dot first. So number of cuts before this were 0. That means the whole grid according to horizontal cuts is there is only one grid. Now if I make one vertical cut, the grid form will become, number of grids will become 2. If I make another cut, the number of grids will become 3. So if I made CNT cuts, the number of grids are CNT plus 1, and then I'm adding A of I dot first into it and incrementing the counter of horizontal cuts. Similarly, what I'm just doing this in with respect to vertical cut, and finally returning the answer. And this is kind of an this would be easy, this is easily solvable with some guesswork, I would say. So that's why 4000 solutions are accepted. There might be other reasons also, but let's just assume that it is because the question was guessable. And talking about rank, my rank is bad, I would say. 191 is bad considering all the participants above me have 1300 rating, 1300, 1600 rating. So that's bad, I would say. So my rating is 152, but this 191 is including the participants from LCCN. I would probably get positive delta, but rank is just bad. I guess that's it from my side, and thank you for watching.